In this video, we're going to get some hands-on time with pig. We're going to use pig to query our data using both the grunt command line interface and the Hue web GUI, and we'll also review some additional online labs and learning resources. You must have been through the pig basics video in order for this video to make any sense. And you also needed to have installed the Quick Start VM or the 4-node cluster with Cloudera Manager. It's also highly suggested that you've been through the MapReduce chapter and the Hive basic usage chapter. It's good to compare and contrast how pig works against Hive. In this exercise, I'm going to be using the Cloudera Quick Start VM, so if you could hop over there with me, and we're going to crack open a terminal, and we're going to maximize this terminal, and we're going to cd into code and data, code and pig basics. And inside of here, you should see one single file, pigexercises.txt. Let's go ahead and run less on that file. And actually, we're going to do the same thing we've done in previous exercises. We'll copy and paste output from here into another terminal. So let's actually move this in a bit and leave a little bit of space for another terminal. And let's go ahead and open a second terminal and maybe space this one over here and give it a little bit more vertical space. So you probably already have this GSOD dataset up in HDFS. Let's double check and see if it's there. We can always do that with the Hadoop fs-ls on that base directory right there. And let's see what we have. We should have a GSOD dataset right here. And actually, it looks like we do not. So let's go ahead and put this data up. And we'll copy the command from over here and paste it over here. And just give that a few minutes. It's quite a large dataset, so it might take some time for it to get up in there. As that's running, let's go ahead and review the rest of what we'll be doing in here. You can push the down arrow to scroll down a bit. And you can see the first thing that we're going to do is fire up the pig grunt terminal, which will wait until this is done loading for us to upload that data. And once that's loaded, we're going to load a subset of our GSOD dataset. So what we're going to do is grab some particular columns out of here, and what we're actually doing is loading this as a character array. If you have fixed width fields, as the GSOD dataset is, you can use this character array to then go in and pull out specific column numbers as various variables inside of there, and then load that data. So what we're going to do, we're going to first trim the data. So we're going to say anything that's a header row should definitely be over 108 characters in length, and we're simply going to run a pig filter operation on that. And then as we capture that data back out, we're going to run this for each generate statement. So we're going to say for each tuple that we have in this list, in data only, we're going to generate a subset of the data out, and we're going to shove that into select columns. And here you can see that we're pulling a substring of this row. For this first example, we have columns 0 through 6, we're saying is the station ID. And then a nice thing too, you can see that we're moving temperature averages around to be next to each other. So the temperature average, min, and max are next to each other, whereas they were in the original data set quite a ways away from each other. And then we're pulling out, again, a few subsets of additional fields. Some of these we'll use in our example. Some of them it's left up to an exercise for the viewer to go ahead and come back and play with those. After we pull that data out, we're going to run a trim, which just removes white space, and then we're going to explicitly cast certain fields into certain data types. And after we've done that, we're going to then run this further filter operation. You can see that we can filter data with multiple conditions. So we can say anytime a temperature average is less than 900 degrees, or a temperature max is less than 900 degrees, and all these other situations, that's when we realize that we have all data. The GSOD dataset, they do something kind of wacky, whereas if they didn't have data for that day, they, for example, put in 999.9 degrees, which doesn't make any sense. So we're going to say we'll pull out only the rows that have all data for all columns. And pig, basically, as you're typing these commands in, pig is just saying, okay, that's valid syntax, until it sees either a store or a dump operation. And once it sees a store operation, as we have here, it goes ahead and runs the scripts, and it will run one or more MapReduce jobs, and then it will spit that data back out into GSOD filtered at the very end. So let's see if our data is uploaded. Okay, finally finished. And let's go ahead and start running these commands. So we're first going to type pig over in our right-hand window to open a grunt terminal. You'll see a bunch of warnings fly by. This is stuff that we could correct later. We're not going to worry about it now. It just talks about some deprecated commands. You don't see any errors here. You just see some warnings and information. So let's copy our first load. Remember, at the top of our pig scripts, we always have to load data. This is a schema on read. So once we've loaded that data, we see that it did in fact load. We got a few more warnings. We're going to then run our second command to do our filter operation. And we copy that over here, paste that back in, and we now have data only is filtered and should have the header rows removed. In this next copy, we're going to grab all of these. So we're going to for each generate across each tuple in data only. And we'll copy this data and go ahead and paste it and push enter. And again, grunt just comes right back and says, okay, that's valid syntax. And then we're going to run our final has all data operation to make sure that we're only grabbing rows that have data for every single column that will be working. We do see a warning here about implicit cast to double. Don't worry about that too much. We could have cleaned that up perhaps by using doubles instead of floats, but not a big deal. And here at the very bottom, we're going to go ahead and issue our store statement, which, as we know, goes ahead and runs the command. So this will actually finally kick the MapReduce job off. And we see that the job is in fact running in the cluster now. And we could even go over to our MapReduce web GUI for our job tracker, which, if you remember, is on port 50030. And we should see this job running. Let's go ahead and take a look to see what this job looks like when it's running as pig. We don't have any jobs running yet. Let's go ahead and refresh our view. Pig is actually building an execution path as the very first thing it does, and it's building several jars and so forth. Because these aren't running yet, let's go ahead and hop back here and see. It actually did kick a job off, 0136. So let's hop back over here and see if that job is running under running jobs. There we go. Finally, we do see it running, and we do see it running under pig Latin. So we see that this was a job that was submitted with pig. And again, we don't see any maps and reduces complete. This will actually be a series of jobs on the load, I believe. So this could take a while. As this is running, let's go ahead and scroll down in our pig basics document, and let's see what else we're going to be doing. So after all of this data has been entered, we're going to flip over to the Hue web GUI, and then we're going to build a sample data set. So we've talked about this in other videos about having really useful sample data and sampling the whole way through a data set. In this case, we're going to flip over to Hue, the web GUI, where we can run pig commands from there as well. And we're going to reload the data that we just output, this GSOD filtered. We'll reload it, and then we can issue this sample command. As you see here, I'm using a pretty standard syntax where all the pig native commands are written in uppercase. And here we can just run this simple command to say we're going to sample a 1% subset. We're putting that into a data bag called sample 1%, and then we can simply store that back out into HDFS. This is very useful. As you can see, this job right now on the full data set is taking quite a while, several minutes probably. We can run further analyses with this 1% cut of the overall data set. We're actually not going to use the 1% cut in our exercises below. So it looks like the job did work. At the very end, you're going to see a job DAG. The DAG stands for Directed Acyclic Graph, and pig typically runs several jobs to complete an overall required operation. So in this case, you see that we ran only one single job, and there's no dependencies on other jobs. Let's pull open another terminal, and let's see if it actually did write the data back out to where we said. If you push up arrow in this document, we said that we were storing this data in input data GSOD filtered. Let's run a Hadoop FS command to see if it's really there. And we're looking for input data / GSOD -filtered. And let's see what we have inside of here. Looks like we've got about 6 megs of data. So we pulled out quite a bit of data from the original data set, and we only have 6 megs to work with now. Pig is very useful for doing things like this, ETL operations or extract, transform, and load operations. Type exit to get out of this terminal, and let's hop into a web GUI. We're going to use Hue as we did in the pig exercise, and when you open Hue, you see several operations that we can do. Here we had the beeswax Hive web GUI that we used in the Hive exercises, and here in the pig editor, we're going to do some further exercises. So this is very nice in that it lets us save scripts and submit them from a web GUI rather than having pig installed on an individual client. So here we're going to run these next commands to generate our sample data set. We're going to just paste this right on in here. And you can see this command, if we hop back over here, instead of loading as a character array, this time we're using pig storage, which is what we can use now because we're not dealing with a fixed width data set. We're dealing with a tab delimited data set that we put back in here. So this time we're using pig storage to do our load, and then we're saying as, and we're explicitly typecasting our individual fields. And this could be very useful. For example, when we want to run order operations and so forth, we need to have variables listed exactly as they are. So integers for station, WBN, and year, month, day, and it looks like floats for everything else, which is going to maintain the precision of those data sets. Let's go ahead and just copy all the rest of these last two, sample 1% and the store command. And we'll go ahead and enter that, paste back over here. And we see that we can actually save this. Let's go ahead and save this script, and let's call it a sample generator. Remove the rest of the data from the end of that, and let's save it. And when we push that big green triangle, we see that we get this running sample generator, and we can actually flip over back to our MapReduce, and we can refresh our view, and hopefully we'll see this running job pop up here pretty soon. Pig is first building an execution path, so it might take a little while for that to come up. But as that's running, let's go ahead and shrink this window back down. This was actually just to show you that you can in fact use the Hue pig editor to do the same things. And we'll go ahead and minimize this view as well, and we'll continue back on the grunt terminal. We're going to push down arrow to scroll this down a bit until we come up to here. You can see that we're issuing another load. Again, grunt is not aware of what we did in Hue, so we've got to go ahead and run this load of our GSOD dataset back. And again, we see that implicit cast. We don't need to worry about that too much. This query is going to answer the question of what was the hottest recorded temperature in 2014. Pig is ordered by a 0 index, so this first index station is going to be index 0, WBAN is going to be index number 1, YMD is going to be index number 2, the average temperature is going to be index number 3, and then what we're interested in, the max temperature is going to be index number 4. So we're actually issuing this order statement, so we're saying order all data by number 4 descending by the 4th column. This is really useful that we can specify columns by their position rather than their name. So let's go ahead and copy that and put it into our grunt terminal. So we're creating this new data bag called hottest, and then we're going to limit to our hottest 50 temperatures. And let's go ahead and do that. We really only need the one hottest, but in this case, we're going to list the 50 so that we can go through and verify that it actually did do what we expected. Now here we're issuing a dump statement rather than a store statement. Again, this will kick off an actual series of executions, and we can go ahead and let that run. You may want to actually pause the video here because this job will take a while. Once you see a final completion and success, let's go ahead and push play on the video. This is going to take maybe 3 or 4 minutes, and it's probably better just to wait until that happens. So I'll come right back when I am finished with my load. So it took me maybe 2 minutes there, but I finally got my dump back out to the terminal. Again, the two options are to either dump or to store. And if we scroll back up, we see that our 0, 1, 2, 3, 4th column, our maximum temperature, is a steamy 118 degrees. So somewhere in the world, it was 118 degrees in this 2014 data set. The unfortunate thing is we don't know where this temperature occurred. We just know that it was, in fact, the maximum temperature. And the reason that I spit out 50 results is you can see it did that order of descending. So the next hottest temperature is 116, 115, 114, and so on down the list. What we would ideally like to do is actually get not only the temperature itself, but also the station that it occurred at. And the GSOD dataset gives us this ISH history.txt file that we can use to join against this dataset. So the very next thing we're going to do is in a brand new Linux terminal. Let's go ahead and just open a new terminal and move this over here. We're going to actually do some manipulation on this file right in the Linux bash script as well. Sometimes it's easier to do analyses, especially on a small file like this. It's easier to do cut operations to actually pull out specific fields that we want. So here we're going to create a tab delimited set of data that we're really interested in. And again, this is station WBAN. I believe this is the station name and then the country and the state that it was in as well. And the map for this is explained up in the very top. If we scroll to the top of this file, you can see that the station data is available here, and it explains exactly where all these rows for the actual GSOD data set, and then when we're dealing with this sample data set for the ISH data, this explains what those individual columns are. This is a bit of a tricky command. We're going to copy this in several parts. We're first going to copy this part, and we're going to go over to our terminal, and we're going to paste just that. The cut command, we can't just specify a \t. It'll put in a literal \t. So what we need to do here is push Control-V and then tab on your keyboard. And you should see it space out as it did on mine. And then we're going to copy the rest of this up to the very last quote. So we're going to, again, copy this and paste it over here in our Linux terminal. And again, this B is just saying we're pulling out these individual column ranges. We're taking what's in this ISH, or this list of stations file, and we're putting it into this cut command, and we're taking the results and we're putting it out into station data only. So let's go ahead and push enter there. And we should have put that data in station data only. Let's now actually put the data up in HDFS so that we can do our pig side join. The Hadoop FS put command will put the data back up in there. Just for grins, let's go ahead and actually cat this file out to see what we have inside of there. We can just do cat and again paste the contents of the station data only and push enter, and sure enough we see that it's a list of the station ID, the WBAN, the station name, which is extremely useful, the country, and the state that it occurred in. So the station ID and the WBAN in the GSOD dataset together makes up a unique identifier for our individual datas, for our individual stations. So now that we've loaded that data up in there, let's go ahead and scroll down a wee bit more with the down arrow. And back in the pig grunt terminal, let's scroll down to the very bottom here. We're going to now join our data sets. So we already have max temps. That was the data that we output here to the terminal. So now we just need to load our stations data. And we're going to copy this data. We see here that we're using pig storage as well. And we're using that tab delimiter that we actually put in our data set. And again, we're specifying the individual types of every field so that we can do correct joins and so forth. And let's push enter. And again, we get that cast to double. We could have gotten around that by perhaps using double rather than floats. And this time we're going to run a join statement. This is an extremely useful thing in both Pig and Hive to be able to do joins inside of here. This would take probably a couple hours to write the raw Java to do this. And here you see that we're actually joining by those two unique identifiers. So the join order in Pig is extremely important. You want your smaller table on the left and your larger table on the right. So in this case, our max temps we know is only these 50 rows of data, whereas our stations data is maybe a couple thousand rows, I believe. So our join operation, if we put our smaller table on the left, is going to be a lot more efficient. And here we're specifying 2 fields to join on. You can also specify just a single field, but that wouldn't do it in our case. So let's go ahead and push enter. Again, Pig just says, okay, that's valid. This time we're going to, again, reorder our data. So our largest data is at the top. Let's go ahead and reorder it, again, by that 4th column. And this time we're going to go ahead and dump our ordered data bag back out. And again, let's go ahead and let that run. And actually, while this is running, let's hop over to our MapReduce terminal. And here, let's go ahead and refresh our view. Here you can see that we had several pig jobs kicked off, these default job names. And these consecutive IDs, this probably indicates that these were part of our DAG, our directed acyclic graph. So it probably ran several jobs in one iteration. And actually, when this job finishes, our job that we're running right now, let's go ahead and take a look at that. But typically, these things are chained back to back. And we can see if we refresh here, we should see one or more jobs running as Pig is kicking off. Let's hop back to our terminal, make sure everything's okay. Looks like it did just kick off this 142 job. Let's go ahead and refresh this. We should see a 142 job popping up here, and sure enough, there she is. Go ahead and pause the video again. I'm going to minimize this window. And when we get to the very end of completion on this job, again, this is only a single job. There'll probably be several jobs involved. Let's go ahead and push play and pick back up where we were. And it took about 3 or 4 minutes for mine to complete, but finally the results came back, and you see that we have our joined data sets. And let's scroll back up to that hottest temperature and see what we have. So that 118 was actually at Learnmonth Airport, and I googled that. That's actually in Western Australia. So if you are watching this video from Western Australia, you have my extreme sympathies. Let's actually scroll up and look at our DAG, and here we see that we ran 1, 2, 3, 4, 5, 6, 7 total jobs. So Pig, when it was building an execution path, it actually ran 7 jobs on our behalf and chained them back to back. We were able to accomplish something super powerful simply by using about 15 or so individual Pig statements with these and the statements above. I would leave it up to the exercise for you to go ahead and try to find answers to these other questions, like what is the hottest recorded temperature in your state? What was the windiest day? What was the hottest temperature in the nation? What was the cloudiest or foggiest day in your state, which you can get from the visibility? It's really fun to go in and play with these data sets and answer all kinds of weird, interesting questions. If you are stuck on any of these questions, there's a good hint. Here you see that I am basically running the question of the hottest recorded temperature in my state. I'm simply providing the Pig Latin for it right down here, and you can always go back and run various other queries on other states, and you can also use a similar type query to this for other questions, but I'll leave that as an exercise for you to go back and complete. I would also leave it as an exercise for you to go ahead and clean up after yourself. So I'm going to issue a quit statement in Pig. This will end the grunt terminal session, and that will pull me back out. I hope you enjoyed this tutorial. There's, again, some additional information down here, some other links to some great resources from Hortonworks, especially. Yahoo are the folks who created Pig, so they're the ones who know the most about it. I'd say especially check out this Hortonworks tutorials URL, and especially the Pig baseball exercises. We actually have a baseball data set that we included in our tarball for this course that'll help you get up and running with that really quick. I hope you enjoyed this, and I hope you continue to explore the Pig interface. In this video, we used Pig to query our dataset, both from the Grunt terminal and from the Hue web GUI, and we reviewed some additional online labs and learning resources.